The indefinite integral. Our objective is to find and use properties of indefinite integrals. The indefinite integral, also known as the antiderivative, is the integral with no limits of integration, an integrand function, the dx, the differential, representing the variable of integration, that equals the antiderivative capital F of x plus c, where c is a number commonly called the constant of integration. Remember that when we take the derivative of a constant, it is 0. So looking back to the integrand, there is a plus 0, of course. Therefore, we have to have that constant in every indefinite integral. And this, of course, capital F is any function for which the derivative of capital F equals lowercase f. This just showing us that capital F represents the antiderivative. Basic integral formulas. We looked at these when we were talking earlier about antiderivatives. This integral is the integral of 1 dx, and therefore the antiderivative of 1 is x. Plus c, of course, there's a constant of integration in all of our antiderivatives or indefinite integrals. We, of course, have our power rule that we're used to, where we add 1 to the exponent, divide by the new exponent, and so on and so forth, with all of the antiderivatives from derivatives that we've already memorized and must continue to memorize. It's a good idea to make flashcards so that we can continue to practice and know these antiderivatives or indefinite integrals. The ones in boxes are ones that are new today based on something that we're going to talk about soon. The properties of indefinite integrals are very similar to the properties of definite integrals, where when we take the derivative of the integral, because that represents the antiderivative, those just cancel each other out and leave us with the integrand function f of x. A sum or difference we can split up into the integral of one of the terms plus the integral of the other term and do each one separately, one at a time. Also, we have a constant multiple of a function that can be pulled out to the outside of the indefinite integral. Let's look at some examples. Find each indefinite integral. So I have a sum here, so I can think of doing these one at a time, but first I'm going to consider rewriting this radical into a power so that I can use my power rule. So instead of square root of x, I'm going to think of this as x to the 1/2, and now I'm ready to take my antiderivative. One at a time because it is a sum, so we can use the property of doing one integral at a time. I add 1 to the exponent, x to the 6th, and multiply by the reciprocal of the new exponent, 1/6, plus 3 is a constant multiple, so it's going to hang out and multiply to the antiderivative of x to the 1/2. Adding 1 to the exponent is 3/2, and notice I left room because I'm going to multiply by the reciprocal of the new exponent, 2/3. Of course, I need a constant of integration plus c, just like I do for any antiderivative. Then I can simplify and rewrite it a little bit neater. So x to the 6th over 6 plus 2x to the 3/2 plus c is a very good answer. Because the original problem was written in root form, sometimes we'll see the answer written in root form. So let's practice writing it that way as well. The denominator of the exponent means the root, so that is the square root of x, and then the numerator is the exponent 3, so square root of x cubed plus c, and this is another excellent answer. Let's find the indefinite integral here. Now when I think of a trig function, I usually want to think which of the trig functions that I know have this trig function as its derivative. And there's nothing that I can think of. When we go back and look at our list, all of my trig functions are listed for their antiderivatives, and I don't see any of them that look like that. So sometimes we need to remember that we are going to need to manipulate these expressions and rewrite it so that we can see something that we have an antiderivative for. So I might think of the fact that cosine squared x means cosine x times cosine x. And then maybe I can rewrite it with the sine x over one of those. So let's see, 1 over cosine x times sine x over cosine x. Now, I cannot do one antiderivative at a time unless it's a sum or difference. This is a product. So I still need to work my way towards one of these antiderivatives that I already know. 1 divided by cosine x is the same as secant x, and sine x divided by cosine x is the same as tangent x. So secant x, tangent x, and now that does look familiar. That one is that. I know the derivative of secant x is secant x tangent x, so therefore the antiderivative of secant x tangent x is secant x, and of course plus a constant of integration. Let's find the indefinite integral of x squared plus 6 divided by x squared plus 1. Remember, we cannot have a quotient and do the antiderivatives of parts of the quotient. We need to make it to something that is from our list and using only properties of indefinite integrals that are true. So here's something that we can think of when we have a quotient is how does the denominator divide into the numerator? Usually we think of that when the denominator is just one term, but in this case it's two terms, so how can we think of that numerator like that denominator? Well, 6 is the same as 1 plus 5. So what if we rewrote this integral to be x squared plus 1 plus 5 over x squared plus 1? Now we have something in common that we can distribute in with the denominator. Here's what I mean. X squared plus 1 divided by x squared plus 1. That's going to simplify quite nicely. And then we'll do another integral. You know what? I can write them in the same integral, so I'm going to do it that way. Plus 5 over x squared plus 1. Now this one is going to simplify, of course, to be 1. Well, with this one, hopefully you recognize it like I do. This is that antiderivative, where we get the inverse tangent from 1 over 1 plus x squared. So if I rewrite 5 as using the constant multiple rule, where it's 5 times 1 over x squared plus 1, now I can take the antiderivative of this with my constant multiple multiplied to it. The antiderivative of 1 is x, and then 5 times the antiderivative of 1 over x squared plus 1, inverse tangent of x, and then of course plus my constant of integration. Thanks for watching.